Okay, so let's start. Today we're going to talk about imaginary unit, which is usually marked as a special variable I. So first, let's see what's the most basic property of this new variable. So somehow we call I the imaginary unit and also called a complex number, but actually I rather to consider it as a polynomial. So what we are going to do is we introduce a new variable I, and this special variable got some certain calculation properties, and then you're just dealing with polynomial about this variable. Okay, so now let's see what's the first we should do. We should discuss about the property. Let's see first. If we consider the special I as a variable, then of course it always have one stuff, which is any variable to the power of 0 is always give you 1. Because that no matter what's your base, to the power of 0, you always got 1. And second, we see the next of 0, we see what if I to the power of 1. Any variable to the power of 1 equals to itself. So the polynomial is equals to I. That's a degree 0 term, degree 1 term of about this variable. And then let's see next. And also why this variable is a special one, because we define I to the power of 2 as -1. And somehow we consider this as a definition of this imaginary unit. So this is one of the most important property about this variable. This new variable I is a special one in the sense that to the power of 2 equals to -1. Okay, and lastly, to the power of 3. Again, we consider I as a variable, so to the power of 3 is just I to the power of 2 times I to the power of, to the power of 1. Then, but we already know that in the previous part, I to the power of 1 equals to I to the power of 2 equals to -1. So this is -1 times I, which is -I. So for that's it. We have degree 0, I to the power of 0 equals to 1, I to the power of 1 equals to I itself, I to the power of 2 equals to -1, and that's our definition. And lastly, I to the power of 3 equals to -I. And here we turn to the magic, the really unique stuff for this new variable, which is we have degree 1, 2, 0, 1, 2, 3, and then let's consider I to the power of 4. So to the power of 4 means this is equal to, I square times I square, 2 plus 2. Then, which we already see this is equals to, remember, let's use a different color here. This one, I to the power 2 is -1. So this is -1 times -1, which is equals to 1. So now we have a special case, which is y equals yi to the power 4, the result equals to 1. And notice that these are the same. So I to the power 4 equals to 1, and which is equals to I to the power 0. So next, I to the power 5. Oh, that change back to black. I to the power 5. So if we consider I to the power 5 again, a useful fact is here, I to the power 4, we already know it's equals to 1. So to the power 5 is just to the power 4 times 1 more. 5 is 4 plus 1. And then we already know I to the power 4 equals to 1. So this is 1 times I to the power 1, which is I. So this is I. And this is the same as here. I to the power 5, because we can decompose it as I to the power 4 times I to the power 1, but I to the power 4 equals to 1. So it's 1 in the multiplication means nothing. So basically it's the same as I to the power 1. Similarly, we have I to the power 6 equals to, first it also contains I to the power 4, but also what left there is I squared. And again, I to the power 4, this part is a very good result. This is always equals to 1 by this fact. Then this is just equals to I squared, and which is -1 by here. Oh. So next, we can keep going, consider I to the power 7, and this is I to the power 4 times I to the power 3. We always like to decompose it as I to the power 4 times some stuff, because we know I to the power 4 is 1, so it's 1 times something else, and 1 times no matter what equals to the second term. So I to the power, this I to the power 7 is the same as I to the power 3, which is -I. So these two are the same. And we can keep going to use this trick, because I to the power 4 is 1, is such a special number. So we can use this fact to calculate an arbitrary large exponential part. For example, we can calculate I to the power 33. If we consider I to the power 33, then more or less what we need is to fat out I to the power 4 as much as we can. Because I to the power 4 equals to 1, so it's nothing in the multiplication. So let's see, 33. What should be the largest 4 it contains? It have I to the power 32, then plus 1. That's 33. And we decompose the 33 as 32 plus 1 because 32, because the fact that 32 equals to 4 times 8, which means I to the power 32 plus 1, first you write it as y to the power 32 times I to the power 1 by the product rule of exponential expression, and then 32 is 4 plus 8, 4 times 8. So this is I to the power 4 times 8. then times I to the power of 1.